NVIDIA AI released Jet-Nemotron, 53x faster hybrid architecture language model series that translates to a 98% cost reduction for inference at scale. Jet-Nemotron leverages post-neural architecture search, PostNAS, to significantly improve inference efficiency by retrofitting pre-trained full-attention models. The process involves freezing the multi-layer perceptron (MLP) weights of the original model to preserve its knowledge and systematically searching for the optimal placement and selection of attention blocks. Most full attention layers are replaced by JetBlock, a dynamic linear attention mechanism built to maximize throughput and minimize cache size, while ensuring some full attention layers are retained for complex reasoning tasks. This hardware-aware approach focuses specifically on generation throughput rather than parameter count, which more accurately reflects practical deployment constraints in long context scenarios. By carefully selecting attention layer configurations and optimizing key hyperparameters like attention head number and key value dimensions, Jet-Nemotron models maintain or surpass state-of-the-art accuracy on standard benchmarks, including MMLU, mathematics, retrieval, coding, and common sense reasoning. The methodology is transparent, with each step of the architecture search documented and empirical results substantiating the efficiency gains. Jet-Nemotron can achieve up to 53.6 times faster inference speed and a drastic reduction in KV cache size on modern hardware without compromising performance. This enables cost-effective scaling of advanced LLM capabilities, broadens deployment possibilities to resource-constrained environments, and presents a practical paradigm for model architecture exploration and adaptation without the financial and technical burden of retraining from scratch.